Hello, this is Ali Kotami. Thanks for taking time out of your busy schedule listening to this presentation. The subject of this presentation is temporary caps over landfill slopes. Temporary caps are becoming very common in the landfill industry, and we have had several projects recently. Design and implementation CQA part of the construction as part of these projects. There are many benefits to the temporary caps that I'm going to go through a few of them here. The first one is the financial benefit of it in terms of delaying construction of the final cover. As you may already know, final cover in the landfill industry is considered an expense that brings no revenue for the operator of the landfill. So the farther they can push construction of funnel cap in the future is better from a financial point of view. So temporary caps can provide that for slopes that have reached final elevations and caps to be installed in the future. Temporary caps also get installed on intermediate slopes. If there is a slope that will have additional fill adjacent to the slope in the future, but that future is not near future, further some years down the road, temporary caps can be installed on the intermediate slope to take benefit of some aspects of the temporary cap. One of the other benefits of temporary caps, it allows settlement, more settlement, not that more settlement in the sense that temporary cap provides the more settlement, but gives time for the landfill slope to settle more, to take benefit of the additional airspace in the future. If a slope has reached 3-to-1 slope and funnel cover gets installed on it, but later on the slope settles, the operator cannot go back and fill that additional airspace as a result of settlement. But if it is a temporary cap that will be removed some years down the road, so some years down the road that additional airspace can be kind of used for additional fill on the slope because before the funnel cover is installed. Another benefit of the temporary cap is that it eliminates percolation of rainwater into the waste below the cap area, and that reduces leachate generation, so saves on the expense and cost of disposing of leachate. Also improve gas collection from waste below the cap, because gas doesn't escape into the air, it stays in that area, so the gas wells collection efficiency goes up. Also, if there are leachate seeps on the slope before the temporary cap is installed, the unpleasant view of the leachate seeps on the slope gets hidden below the temporary cap, so it has an aesthetic aspect to it. I'm not saying that the leachate seeps will stop. Leachate seeps may continue below the temporary cap, but the neighbors won't be able to see the leachate seeps anymore. It may also improve odor problems at the site, and gas doesn't get into the environment, it goes in through the collection system and through the gas valve, so it may have benefits to the odor addressing odor problems at the site. There's some preparation that needs to be done as part of the construction of the cap. First, all large objects from the slope needs to be removed. Large object could be large gradation soils, stones like boulders, not boulders necessarily, but large pieces of rocks that may impact integrity of geomembrane. Also, large size vegetation needs to be removed before the geomembrane is installed. If the thickness of the geomembrane is like in the order of 40 mil, probably fine vegetation can stay on the slope. It won't harm the geomembrane. But if the geomembrane is a thin geomembrane, like a 20 mil geomembrane, you may need to remove and strip the slope of all vegetation and even put a fine graded soil over the slope to protect the geomembrane against any damage. If there are gas wells or gas pipes coming out of the slope, naturally we would have to install geomembrane boots at every penetration. This may also include some other components such as condensate sumps or anything that may exist in the slope area. And also after installation of geomembrane, we have to provide ballasting to keep the geomembrane in place during high winds. So uplift is a big issue, then the ballasting needs to be addressed, the uplift. For if you're using sandbags and ropes, then they need to be ultraviolet resistive bags and ropes in order to last for a number of years. There are sandbags and there are ropes in the market that have a certified 10-year life, and those are all ultraviolet resistive bags and ropes. One important feature of temporary caps is that rainfall over temporary caps gives you 100% runoff. So you would have to provide drainage pathways at the bottom of the slope or somewhere on the slope, however the design works out, to address the volume of runoff reaching certain points. And if you get a large rainfall over the capped area, you will have to handle a large volume of water as runoff at some point on the slope. Also, if there were seeps on the slope before the temporary cap installed, seeps, like I indicated earlier, continue coming out of the slope below the cap and possibly reaching the bottom of the slope. Some sort of system is needed to address seeps below the cap. You don't want the seeps get off the lined area and cause other compliance issues. There's maintenance involved with temporary caps. One of them is repair of geomembrane boots at penetration points, gas wells, any pipes that penetrate the geomembrane. Because this is an exposed geomembrane, and you get expansion and contraction in the geomembrane, and the boots may get impacted as a result of this compaction or contraction and expansion. So damage may become visible at the boots that needs to be repaired. Also, if the temporary cap stays in place for a long time, so the integrity of sandbags or the ropes may get affected as a result of ultraviolet radiation, and at some point the elements need to be replaced. When it comes to removal of the caps, the recommendation is to remove it in stages. Let's say you had a temporary cap over a temporary slope. The fill on the adjacent area is started, the fill is going against the area that the temporary cap is in place. The recommendation is not to remove the entire temporary cap and remove it in stages to take benefit of the area that is still covered with temporary cap and doesn't need to be exposed for some time. In that case, it is highly recommended that you think ahead of time with respect to the diversion of runoff water as the result of changing the geometry of the temporary cap. The water runoff has to go somewhere. That needs to be thought of ahead of time. I'm going to go through a number of pictures for two cases. These are temporary caps that were installed over the past recent years, and I want to share some pictures with you. The first one is a subtitle D landfill in South Florida, and what you see in front of you is the temporary slope that additional fill will go against this slope some years down the road, and they wanted to protect this slope with temporary cap to reduce leachate generation, to address the better gas collection efficiency out of the slope. And also there were seeps, leachate seeps on the slope that they wanted to kind of improve aesthetics of the slope. See, in this slide, the geomembrane is installed, sandbags are placed at 10-foot spacing. The ropes are not pulled yet, but it will be done at a later stage. This is the larger view of the entire area. It's close to 20 acres of temporary cap. The anchor trench is shown in the middle of the slide at the top of the slope, and in the area, lined area, you see the penetration of gas wells, and there were condensate sumps. There are other pipes that were penetrating the geomembrane. There were many penetrations that they had to boot them. This is a view of the slope from the bottom. In the foreground to the right, you see a penetration of a condensate sump and the piping stuff and the electrical associated with it. Near the top, a couple of other pipes are visible that penetrated the geomembrane. This slide shows the drainage pathway near the bottom of the slope. It's a lined temporary ditch at the bottom of the slope, or runoff gets in this ditch and then goes through at certain points through HDPE pipes through the body of the berm to the left side of the slide, which is a landfill, the permanent drainage ditch, and two of the HDPE pipes draining the temporary ditch are visible, and they use riprap at the outlet of the pipes to kind of prevent soil erosion at the point of discharge. This feature, the temporary ditch, is extremely important for temporary caps. This is a view of the final product. The ropes are installed but are not visible in this picture. It's a fairly large area that was temporarily capped. Near the top of the slope on the profile of the landfill, you see some very in the shaded shades of vertical sticks. Those are 4x4 wood posts that were installed in the anchor trench of the temporary cap, and the ropes were tied to these wood posts to secure the ballasting system. Case 2 is a slightly different land. It's an ash monofill, no penetrations through the geomembrane. It was a very nice project. A lot of design work went into it. Some grading needed to be done for this area in order to install the temporary cap, and also we use sandbags for this project as well, with the straps connecting the sandbags together. To the left side, you see the wood posts that were installed in the temporary anchor trench for connecting the straps to the wood posts. There were two distinct areas included in this temporary cap. One area was below a road that I'm going to show you in a minute. It has reached the final grades 3:1. They didn't want to install the final cover, but they wanted to temporarily cover it with temporary cap. And above the road was temporary slope that additional fill or additional ash was going to be placed over the temporary slope some years down the road, but they wanted to cover it temporarily with geomembrane. The purpose behind installing temporary cap was to reduce leachate generation. This is a section of the slopes. It was a very clean job that the contractor did, and the rows of sandbags and the straps are very visible in this case. This is an area above the road that I'm going to show you in a minute. This is the temporary slope that additional fill is going to go against it. At some points at the perimeter of the temporary cap, we provided drainage pathway. You see here the lined ditch is part of that temporary pathway, leading to a permanent existing concrete lined ditch next to an access road. So water off the temporary cap gets into the concrete ditch, goes to the bottom of the slope to the permanent drainage ditches around the landfill. Here is the road that I mentioned earlier. The area to the right is the final 3-to-1 slope of the landfill that's temporarily covered. To the left side of the road is the temporary slope that additional fill will go over it. The client wanted the final road constructed as part of this construction. So we provided all the geosynthetics that's needed as part of the cover system, final cover system, below the road area before the base layer and sub-base layer were constructed, and finally they wanted the top surface to be paved. Here it shows the wood posts, the 4x4s that go into the anchor trench, and the straps are tied to the wood posts in order to secure the ballasting system. Here is a view of the top area. Like I said, there was some grading involved in this project, so we graded this slope as part of the design and the earthwork in the field in order to get the runoff to the right areas that we wanted to get to. To the right side of the slope, the wood posts are visible at the anchor trench of the temporary cap. This is standing at the top looking down. The slope in front of the slide is like a 3-to-1 slope looking down. In the middle of the slide is a flatter slope, but sloping to the right in order to get the runoff to the right side of the south. We are looking south in this picture, and the incinerator is visible in the upper part of the slide. This is to the west side of the ash monofill. The area at the bottom that looks like a ponded water is a small retention for catching the runoff, and there was an existing culvert in the middle of that retention area. Before the work started, we took benefit of that existing culvert in order to drain water to the bottom of the slope to the right side of the slide into the permanent perimeter ditch of the landfill. This is looking south again, is a temporary slope above the road that is visible in the middle of the slide. Areas that we couldn't have a temporary ditch, we provided a berm type of a slope in order to keep the water runoff water within the lined area, leading it to the discharge point. Another view of the temporary slope above the road. The road is shown in the middle of the slide, and as you see, the runoff flows to the near the road and then goes to the right side, which there is a discharge point. There's also, we lined the side slope of the road is visible in this slide in order to protect the road structure against runoff coming down the slope and hitting that side slope of the road structure. So we wanted to secure that road structure as well. This is the top area, another view of it. At the low point, as you see, is a sloping toward the low point. We are looking east in this slope. I showed you another slide earlier that was taken from the upper part of the slope on the left side, looking south. With that, I conclude my presentation. I thank you for taking time out of your busy schedule looking at this presentation. If you have any questions regarding temporary caps, don't hesitate to contact me via my email or my cell at 561-441-1473. Thank you again.